Okay, so we've got Ollie today. He's going to be talking to us about all things to do with the weather on Earth this year. So take it away.
Morning, everyone. Thanks for coming along today. I apologise if I've forgotten what the next planet is. Something to do with planets. So we're just going to get stuck straight in. So the reason I say Earth is my favourite exoplanet is because it's not the same planet it once was, I don't think. I mean, you've probably seen this a million times already. Global temperature change since pre-industrial times, ish. It's just not, I mean, we're just in a completely different ballpark now. I think about 1 degree above normal, above the pre-industrial baseline now, above the 1950, 1980 mean. So it's just not the same planet anymore. I mean, we talk about sort of, there's no planet B. Is there even a planet A anymore? But before I get into that, I just want to talk a little bit about some of the crazy stuff that's happened this year. Because it's been a bonkers year, and it all sort of kicked off big time. Sort of April, May, and to an extent June as well. Sort of in much of Asia, where there was the historic heat wave. The World Weather Attribution described it as virtually impossible without climate change. And they determined this from basically running a model without any sort of greenhouse gases put into it, and just to see how frequently you've got sort of an ensemble of runs. And you basically see how many of these ensembles have sort of an extreme weather event, such as the one we saw in April, May in Asia. And essentially none of them had the sort of extent of this heat wave in them at all. So you can basically conclude from that human forcings allowed this to happen and allowed it to be so persistent. I mean, this wasn't just, I mean, we had the heat wave last year in the UK, which was like a 2-day affair, 40 degrees. Which was exceptional, but you know the impacts are going to be quite limited over 2 days. This was weeks on end of just record-breaking temperatures continuously, and particularly in Southeast Asia, it was the epicenter. So these are just some of the temperature records we saw. Thailand, for example, in April recorded their first ever temperature above 45 degrees Celsius. Now these get into almost lethal sort of temperatures when you consider the humidity as well. I mean, these are really dangerous temperatures. Vietnam and Laos as well both recorded, well, smashed their all-time records in May as well. And Singapore recorded their hottest May ever in history. So really extreme stuff. And it wasn't just limited to Southeast Asia as well, much of Eastern Asia as well. China in particular, they've had a terrible time recently. Last year, it was bone dry, hardly a drop of rain recently. And this just exacerbates the impacts of any heat waves that form. So, for example, much of Eastern China, temperatures in excess of 36 degrees across numerous cities for weeks on end. And Hong Kong recorded a new June record of 37.9 degrees Celsius, which when you consider the humidity in South China, is just really brutal heat. And, you know, without human intervention, like sort of air conditioning and stuff, I don't know how you can cope with these conditions. Japan as well, the Japanese Meteorological Agency reported their hottest ever spring period, their March, April, May period, just completely above anything ever seen. It's just incredible stuff. So then we move on this was, as that was going on, we had an incredible heat wave in North America. So this was the mean temperature anomaly for May 2023. This graphic was from a guy called Scott Duncan, who does absolutely fantastic graphics on all things climate and weather. And you can see just enormous anomalies. I mean, this is for the month as a whole, and it's just off the scale. You know, you talk sort of 7 degrees above average, which for a day would be a very sort of noticeably warm day. For a month, I mean, it's just staggering. There's no words for it really. For example, I'm pronounce this wrong now, Nunavut, I think it is, Arviat, they exceeded their previous May record by an enormous 6.7 degrees Celsius. That is the largest sort of temperature departure on an all-time record I've ever seen. I mean, for example, the 40 degrees we saw in the UK last year, that was, I think, 1.6 degrees Celsius. So to exceed it by 6.7 degrees Celsius, I mean, it's just, I don't know how it's possible, to be honest. And this was during a time when, you know, the Hudson Bay is frozen over. Well, much of it is still frozen at this time. So, you know, you just got an advection of this heat just being pumped up from the south. sort of heat dome forming on there. Talk a little bit more about those heat domes in a bit. And this contributed to the ongoing wildfire season being the worst in history. I mean, it's just a tinderbox there. It's just been weeks on end of high pressure, dry conditions, lots of sunshine, perfect conditions for wildfires to form and to stay and to just keep going. So this is a little bit out of date. This was from the 14th of July. I've really struggled to keep up with just how many records are falling. I mean, I've been trying to update these slides as I've been going along, but it's just every day some new record is falling. It's just extraordinary stuff. So you can see, just how much land has burned already in Canada. It's just way above anything seen, really. So the impacts of this, I mean, it's just a tin box. Everything's alight, just burning, all the way from sort of Western Canada, Alberta, British Columbia, all the way into the east as well. So you probably saw photos like this during June of New York and a lot of the east coast of the US being obscured by wildfire smoke and other aerosols. And the air quality is truly horrendous. I mean, for a time it was the worst. I think it was the worst ever seen in that city, or at least one of the worst. It was just, you couldn't breathe the air. It was just awful conditions. And eventually we saw that wildfire smoke being moved across the Atlantic by the jet stream. And that brought quite, not as bad impacts, but pretty non-ideal conditions to Western Europe. So here's a sort of zoomed in view. So all this smoke actually originates in Canada and has just been shunted along by the jet stream all the way to Europe. That's a huge amount of smoke, and we actually saw impacts on air quality in parts of Iberia. So that was Asia, North America. Europe wasn't spared either. The UK had its hottest June on record, way above anything seen before. So the previous record was 1976, and I believe 1940 as well. Both of those were 14.9 degrees Celsius as a UK mean. I mean, we're just well above that, 0.9 degrees above the previous hottest June on record. And this was due to blocking high pressures sort of over Europe, dragging up this warm air from the continent and sort of a weakened Azores high, so that we had sort of a predominance of southeasterly winds just keeping things very warm for a very long time. The UK wasn't alone. Much of Western Europe saw their hottest, or one of their hottest Junes on record. I feel like a broken record here saying hottest on record, but it just keeps going. It just doesn't end. And this contributed to, partially contributed to sea surface temperature anomalies in the North Atlantic being just way, I mean, I can't even say they're way above anything I've seen before. It's just a completely different level now. It's not the same planet anymore. It's just extraordinary. I mean, for a time in June, we saw temperature anomalies of around +6 degrees in the water around the UK. I mean, +6 for ocean. I mean, it takes about 3,000 times as much energy to heat water as it does air. So there's an enormous store of heat in the oceans at the moment, which could have pretty unideal impacts further down the line. I just want to show you this plot. I mean, a lot of you have probably already seen this because I posted in the climate group chat a lot, but this it just leaves me speechless. I mean, there's just no words for this. This is the latest one. It's just completely off the scale. I mean, scientists are struggling to understand what is happening. The oceans, they just keep getting hotter and hotter and hotter. But we don't expect, I mean, you don't expect ocean temperatures to be, sort of almost a degree above anything ever seen before this time of year. It's just incredible. So why has it been so warm in the North Atlantic? Well, there's a couple of ideas. I spoke about the aerosols one, the shipping ones before, but another contributing factor might be sort of a lack of Saharan dust over the Atlantic during June. So normally you've got the Azores high, and you've got these easterly trade winds that drag in dust from the Sahara. And of course, dust helps to block a lot of the sunlight from reaching the ocean, so it keeps things a bit cooler. But we saw quite a weak Azores high this year and a weakening of those trade winds. So less dust was being sort of evected over the North Atlantic and preventing that cooling from happening. Another sort of very contentious possibility is new regulations and how much sulfur that ships can emit. So normally ships burn quite a dirty kind of fuel that has quite a bit of sulfur in it. But in January 2020, there was new regulations that reduced how much sulfur in these fuels that ships could burn. I think it was a drop from 3.5% to 0.5%, which is quite a substantial drop. And there's a potential that this has actually allowed more sunlight to reach the oceans. You know, you've got less cooling from these aerosols, particularly over the North Atlantic, where most of these ships, you know, do trade with the Americas, North America and Europe. So you see here the sort of the amount of the emissions plummeted in 2020, and we may be potentially seeing the impacts of that starting to grow and grow over the years. If we are, this will only get worse over the next few years as, you know, that heat accumulates. Bit of a termination shock. So yeah, I talked about the other contributing factor was that weak trade winds. And that was due to a weakening of the Azores high. We saw one of the weakest Azores high on record. So the Azores high is a region of high pressure in the North Atlantic that forms basically due to the happy cells, and where they sort of converge, sort of get subsidence and sort of lack of convection. But that was quite weak during June, so we basically saw, you know, those trade winds being a lot weaker, less Saharan dust being dragged away. So yeah, those are just some of the ideas on why the North Atlantic is just so hot. But I mean, you wouldn't expect to see 1.5 degrees above average for an entire half of an ocean. I mean, that's just, there's no words for it really. So, oh yeah, this is a little bit on the Azores high. There's actually some evidence it may be expanding. So the hot summers of 2018 and 2022, they were due to quite a lot of high pressure over the UK. And when we get that high pressure in summer, you know, lack of cloud, lack of rainfall, it allows heat to build quite substantially. And so there may be sort of suggestions that Azores is actually expanding, mostly during winter, potentially during summer as well. So I showed the temperature anomaly for the North Atlantic, and that was, I mean, that was just completely off the scale. But the global situation isn't much better. You can't quite see, but this is 60 degrees south to 60 degrees north of the entire globe. And we're just way above anything ever seen at this time of year as well. And we're almost above any sort of, actually, I think we are above any record seen before, even during the periods when the oceans are hottest, sort of February time globally. So yeah, globally historic, regionally historic as well. It's just incredible stuff. And this is before El Nino has even got going. So we're actually leaving La Nina, which is a cooling of the Pacific, which has been going on for a couple of years now. We're actually entering into the El Nino stage, which is a substantial warming in the Pacific. And if that is a very strong warming, like we saw in 2015 or 2016, you know, I don't know how high this could go. I mean, we don't know what the ceiling is, to be honest. So that was the ocean situation. But I want to talk a bit about the sort of land situation. I mean, you've probably seen those videos from the Greek islands of the wildfires that have been going on, you know, sort of North America as well, the intense heat waves. And these are due to something called heat domes. So a heat dome is essentially just a region of high pressure that gets stuck on a region and isn't shoved away like it normally would be. It just tends to get stuck in one region. So you can see here, this is the geopotential height anomaly chart. No, this is raw geopotential height. So that's essentially the height of the 500 millibar level of the surface. So the redder colors are basically higher pressure, so more atmosphere in that region, and blue is sort of low pressure. So you can see these sort of distinct zones. I'll zoom in a bit. You've got these different zones. So you've got heat dome over sort of North Mexico, southern US. You've got heat dome over Europe. We had another heat dome sort of over China and much of Asia. And these are horrendous things because they just get stuck in one place and they just keep heating, and there's just nowhere for that heat to go. It just stays in one spot. And you just see extraordinary temperatures. I mean, Death Valley, I think, actually got 53.9 degrees Celsius recently. the Mediterranean, only yesterday it got to 48.2 degrees Celsius in Sicily, I think, which is maybe not Sicily, but it was one of the islands around Italy. But that's the second hottest European temperature ever recorded, and the hottest ever was in 2021, 48.8. So, we're just rapidly breaking these records now. It was the hottest ever July temperature, so there's a record there. And part of the Xinjiang province, Sambao, I think it was 52.2 degrees Celsius, which exceeded the Chinese record by over 2 degrees Celsius, I think. Just incredible stuff. I mean, the margins were breaking these records. Normally you break records by fractions of degrees because, they're on the extreme ends of climatology. But we've just entered into a new climatology. We don't know what those extreme ends are anymore. I mean, it's not ideal. So how do these Rossby waves, heat domes, get sort of stuck in place? So I don't know a huge amount about these, but Rossby waves, they essentially propagate energy through the atmosphere. So normally these would move from east to west. They move across the globe, and they sort of act as, at least the boundary between them is sort of the jet stream. So they sort of move along. You can imagine these waves moving. Normally they move from east to west, and this boundary would be the jet stream. Now, sometimes, particularly during summer, you get sort of a weakening of the jet stream because the temperature difference between the pole and the equator lessens. And so it becomes a bit more sort of high amplitude and it's a bit more elongated. And sometimes the atmosphere can act as a waveguide, so it can actually amplify these Rossby waves. You can get stronger high pressures and stronger low pressures. So when you get something like this, you get blocking high here. And sometimes these can become standing waves, so they just get stuck in place in a very high amplitude way. And when these get stuck, you just got to build and build heat in that one region. Particularly during over subtropical regions, this can be really quite disastrous because you've got really strong sun, bone dry conditions. The heat just builds and builds and builds. So yeah, so you've got this region of high pressure, and it's not moving, it's not being shunted along by the atmosphere, so it just gets stuck in one place. And with the high pressure, the air is sinking. So as this air sinks, it becomes compressed. Sort of adiabatic warming, especially if it's very dry, it will just heat up and heat up as it sinks. And day on day, this heat will just get more and more and more intense. And the relative humidity will drop substantially as well, and that will dry the soils. And it's a horrible feedback loop of drying, heating, and it just results in these extraordinary temperatures that we've seen recently over the last few weeks. So this is actually out of date already, but this was the forecast from last week, and you can see just day on day, like this sort of heat building. This heat dome over southern Europe has just stayed. This is actually sort of undercooking the temperatures a bit. This week, I think it was in this region, we had sort of 48 degrees Celsius, parts of Greece up to close to 46 degrees Celsius. I mean, these are not normal temperatures in Europe. I think we've become quite desensitized to see, 40 degrees plus in Europe. That is not normal. Average highs in this region, maybe sort of low 30s at a stretch, but, way above that. Some of the anomalies were sort of 15 degrees Celsius above average, and parts of Tunisia as well, sort of North Africa, getting close to 50 degrees Celsius, which is just really horrendous heat, borderline unsurvivable heat for long periods of time. So that's the land situation. So the oceans, way hotter than anything we've seen before. Globally, the mean temperatures, we were actually record breaking. I forgot to include the slide here, but we actually exceeded the all-time mean 2 meter temperature record for days on end, I think, already this month. It was 17.2 degrees Celsius or something like that. So the land is roasting, the oceans are just way above anything we've ever seen before. And the sea ice situation over Antarctica is just, I've used this word a lot, but it's staggering as well. So this is from 1991 to 2023, the sea ice extent. It's an anomaly, extent anomaly. So the mean line is the average of the 1991 to 2020. So that's the average amount of ice. And you can see we're well below that. And this plot here is actually 6 standard deviations below normal. So you can see the variability in the summer in the Antarctica. So January time is quite high, you know, because you've got that extra sunlight. But variability during winter is normally quite low because, you know, no sunlight. It gets incredibly cold at the Antarctic continent. But we're reaching, I think this is actually out of date as well. We're actually 6.4 standard deviations below average, which I think is a 1 in 13 billion event. So yeah, basically not possible that climate change again. And in fact, we actually saw a net decrease in sea ice extent quite recently. I think it was over the weekend. We actually saw a drop in sea ice over Antarctica, which, you know, when you're already this low, and normally you'd expect, so this is absolute sea ice extent. So this would be increasing during the winter into the spring and then drop during the Antarctic spring. But we actually saw a net decrease, even though we're way below anything else. So not an ideal situation to be in. So yeah, sea ice, oceans, land, it's all on fire and it's all going horribly wrong. This is just for fun. This is also out of date, unfortunately. I don't know when this was made. This was made few days ago, but it's already out of date. But this is essentially if ocean temperature, global average temperatures followed the same as the super El Nino years of 2015 and 16. Basically, how hot could we expect? So if this coming El Nino is as intense as the one back in 2015, how hot could the global situation be? So you can see by sort of close to December time, we're above 2 degrees Celsius temporarily. This isn't sort of exceeding those limits, but temporarily exceeding 2 degrees Celsius, which had never happened before. And then, you know, sort of early next year, so going into 2024, if we follow the 2016 trend, getting close to 2.4 degrees Celsius above the 1850 to 1900 mean, which would just be incredible. I mean, just way above anything else. This is not forecast. This is just fun, basically showing what could potentially happen if we follow the same trend. But yeah, it's not ideal. It shows a limit of like physical plausibility, or maybe it doesn't. Maybe it could be even hotter. I don't know. Got some other bonkersness. So this is a plot over the Caribbean. So this is the ECMWF does these extreme forecast indexes. So one is basically record breaking, never seen before. And yeah, we've got something. Yeah, it's basically Caribbean situation is absolutely horrendous. In Florida, oh, there we go. I remember to include the plot.
You say one was record breaking and there's two there.
So I thought one was record breaking, but I didn't notice the twos. So maybe that's like beyond record breaking or something. It's pretty extraordinary. I mean, we've got sort of sea surface temperatures on the south coast of Florida. I think they hit 101 degrees Fahrenheit, which is 38.4 degrees Celsius, which is a new all-time record, which will be maybe confirmed by the WMO, World Meteorological Organization, over the next few weeks. But that was hit just yesterday. So yeah, another record to add to the pot. I've got a photo of the wildfire in Rhodes. There's that new all-time record, all-time July record, not all-time global record, that was set 2 years ago. All-time European record, that was set 2 years ago. And also I want to talk about this plot as well, because there's been lots of misinformation about, you know, that the scientists are fudging these numbers because the EU METSAT, they released this diagram of the land surface temperatures. So satellites can't actually measure 2-meter air temperature. They can only measure skin temperature, so the actual temperature of the surface. And a lot of people are saying, oh, well, you know, is that a skin temperature? Is that the temperature of the ground, you know, of a road or something? No, it's not. This is 2 meters above the ground. The skin surface temperatures will always be substantially hotter, but we never do world records in terms of skin temperatures. You know, because if you've got a bit of tarmac, that's going to be like 80 degrees Celsius. It doesn't really make much sense to use that as a climate record thing. So yeah, okay, sorry for the bummer. But where do we go from here? So we'll keep seeing warming so long as more energy is going into the system than is leaving the system. So this is probably the most important plot in terms of the climate, you know, climate change crisis. And as long as, you know, the absorbed solar radiation is more than the outgoing, until these are equal, we're just going to keep warming and warming and warming. And even when they equal out, that doesn't mean temperature is going to drop like immediately. We're just going to be in equilibrium. It'll take time for the oceans to reabsorb that CO2, even if we cut emissions completely. So yeah, it's not looking particularly great. But there's a nice, pretty picture of the, oh, never mind. That's what we get. That should play, maybe. I thought that looked quite nice. It's the Japanese meteorological agency satellite, I think. I can't remember exactly. I thought that was quite cool. So yeah, thanks everyone. Oh, a little bonus. I got somewhat of a heat dome from my own weather station. This was back in August 2022. So this is an inflated Azores high. So normally it'd be sort of here. And we'd be under low pressure like now. Absolute garbage weather. But last year we had a nice sort of, well, I like the sunshine, so it was nice for me, I guess. But we had sort of an extension of the Azores high. And we saw bone dry conditions. You can see sort of surface temperature 6 degrees above average for the first half of August. And this was from my weather station, day on day. So this is what happens in a heat dome. Day on day, the heat just builds and builds and builds. As you've got that sunshine coming in through the high pressure, unimpeded by clouds, sort of low relative humidities as well. Just sort of builds and builds and builds. Okay, and that's it. Thanks, everyone.
Got any questions?
Is it thought that the new, like the sort of trend, the changing ocean temperatures is likely to stick, and that's going to become like it's not going to drop back down again next year? That likely?
I mean, it probably will drop down. I think we're at an extreme point now. But I mean, we said that back in June. It was 1.3 degrees above average, and it's like that's pretty extreme. It'll probably tick down. It just didn't. It just kept going up to 1.5. Yeah, I don't know, to be honest.
Yeah, could you go back to your sort of, you did the dust from the Saharan and the and the aerosol stuff, because you had like quite a decent optical depth coming from the smoke. I was wondering how that compared to like this stuff. Yeah, the side before. Yeah, like the optical depth from that smoke is quite high compared to like the dust. So it's surprising that we got such a crazy high heating up there.
Yeah.
Oh, that's really good. Okay. Yeah, I guess you are really quite high up there.
That is actually it was cold during June, but right now it's the most anomalous place on Earth at the moment in terms of sea temperatures. I think some of the sea surface temperature anomalies were 9 degrees Celsius above average, which is just nuts, absolutely nuts. And you wouldn't expect such heat there because you've got sort of cold ocean water, but I don't know what's happened to that. It's just stopped. But yeah, that is now the most enormously warm place.
You still got that much smoke? Because obviously Canada's still on fire.
I don't know, to be honest. I don't think so. At least it hasn't come this way. Yeah, it's pretty nuts. I mean, 9 degrees Celsius for like ocean, it shouldn't happen. And yet it did. So yeah.
I kind of, in line with kind of Sahara dust and other things, it feels like there's something in them which the models aren't capturing, which kind of therefore means the predictions of how things will be sort of going forward aren't necessarily kind of are underestimating. Do you have any thoughts on that?
Yeah, so there'll be natural variability on top of the sort of the human forcings. So sometimes they'll work against human forcing and keep things cooler. But this was kind of a perfect storm of natural variability on top of human forcings, resulting in this extreme, probably temporary warming.
But do you really think it could just be natural variability on top of kind of climate models, or would someone kind of consider that as?
So that the climate projections are they're normally means rather than short periods of time. So they might not capture a short-term extreme warming. Like over the year, we won't see such big anomalies, because it'll be averaged out over a long period of time. But yeah, it's incredibly difficult to pick up on very short-term things, over a few months with these sort of long-range models. So the climate projections is normally sort of smoothed out mean. But yeah, I mean, if we see this in the future again, you know, it could be even hotter than anyone ever imagined, you know.
On the next slide, I probably just misunderstood it, but were you saying that there's a suggestion that making the fuel cleaner is having an adverse effect?
Yeah, so that's the idea is because sulfur can help sort of brighten clouds. There was a preprint I should have added looking at the sort of the brightness of clouds over sort of coastal Namibia. And they found a decrease after these new regulations because the aerosols help to sort of brighten the clouds, make them more reflective. And it's also potentially helped to keep Europe cool during the 1980s when they burned a lot of coal. A lot of that sulfur helped to keep the European continent cooler.
On that, has it, I mean, there is this mechanism, but do the numbers add up? Has it been modeled?
The
effect of like the new policies to reduce sulfur emission. Has it been modeled, you know, over all of the oceans to see if it can actually create that much heating?
I think so. Yeah, I'll need to hunt down the sort. There was some like preprint stuff on it because it is quite a new idea. But yeah, I'll hunt some of that down. But it's not just due to this. It could have been like a contributing factor to it. There was probably a lot of other stuff going on, and maybe this just helped to tick it up by another, you know, 0.2 or 0.3 degrees on top of the other variability going on.
Yeah.
So it's not like it was just this, it was probably a combination of many different things.
Why don't people trust China's ability to make temperature measurements? So I saw like there were like records in China that was like unconfirmed because why can't China? Why do people think China can make thermometers?
So that particular, I think it was the Sanbao reading, I think it was something like that. It was quite a young station, so it didn't have one like historical precedence, I guess. So I guess it comes down to sort of personal opinion of how much you trust a region that wasn't ever sampled for decades, and then you get a reading and you say, oh look, the planet's warmed this much in this particular region. But that's not a problem, you know, unique to China, that's anywhere. If you add a new station, I mean, a lot of people have problems with this sort of the Heathrow weather station. You say, you know, you've got planes flying over. How can you trust those readings? And then we had the hottest temperature on record nowhere near an airport. It was like in Lincolnshire. So yeah, it's a lot of opinions and stuff.
So is it not that they don't trust China's temperature measurements to be accurate, but that they can't confirm that it's record breaking because they haven't had measurements in that area?
Yeah, I think it's more that one. I mean, there's sort of standards, global standards for measuring this temperature stuff. So you can trust most readings. I mean, also if it's sort of quite a remote station and you can't compare with local ones so much, or if it's substantially higher than local ones, then you know alarm bells might be ringing. But I mean, if it's the only observation you've got, you know, you've got to give them some trust.
Yeah, okay.
This might be just because I don't know that much about weather, but obviously it's super hot in Europe, and you're saying it's got this like static heat dome. Is that why it's like less hot here? Is it because the air is not moving here? Because obviously it's like really kind of not that hot in the UK.
Yeah, so we've had garbage weather here because the jet stream has been sort of a bit further south than usual, but that's helped to sort of keep a lid. It's almost like a pressure cooker, just keeps that lid on that heat and prevents it sort of mixing and vecting northwards. So we had a similar thing in August 2021 where we had sort of pretty rubbish weather here, but we had the sort of all-time record in Europe, 48.8 I think it was, which is staggering heat for Europe. I mean, 48.8 is just, I can't even imagine like living in that heat, you know, going to work in that heat. It's just unimaginable.
Oh yeah, no, it's another question.
Yeah.
I just want to say, Ollie, thank you so much for your talk. That was an amazing talk. You give amazing talks and you're super well informed. So thank you for sharing that.
Thank you. Thanks everyone for coming along. I really appreciate this, the support and stuff you.
Well, oh, I completely neglected you guys online. So I hope you didn't have any questions and that you enjoyed it.